So, hello everybody. My name is Yakir Kotkoda.
And I am Eli Goldman.
And we are security researchers at Aqua Security. And in this session, we'll demonstrate to you several vulnerabilities and flaws that we found in various platforms. There will be a lot of mitigations and examples, so it might be a little bit intense, but trust us, it's worth it.
Okay. So first, we'd like to start with our mindset for this research. Here in front of you, there are 4 famous articles about supply chain attacks. Each one of them had or could have had destructive effects. Now, each one of them has its own story behind it. Some began because of a secret exposed in a Docker image file. Other maybe because a developer was hacked. The possibilities are endless. We see all the time today publications of a malicious Python package was uploaded to PewPie. And this is a good thing. It's a good step to an aware community. But for us to be aware, we don't just need to seek out malicious packages in the platform for where you consume our dependencies from. We need to understand what makes an attack a supply chain attack, understand our organization's exposure to supply chain attack, and defend at each point of exposure. Because attackers today have many entry points from the moment the developer writes this code on his laptop until the binary is running production. That is why we want to raise awareness about attacks in each phase of the cloud development flow. This is how we perceive it. We'll show you today research we've conducted in each one of the phases, starting with the IDE phase. This phase includes all the attacks on the platform where the developer writes his code. It can be VS Code, Sublime, and IntelliJ. Then we'll move on to the SCM phase. This phase includes all the attack on where the organization store their code. It can be GitHub, GitLab, and Bitbucket. Then we'll move on to the registry phase. This phase includes all attacks on the platform where we consume our dependencies from. It can be PewPie and NPM. Now, after we stored our code in the SCM, we take all this code, combine it with the packages from NPM, for example, from the registry phase, into the CI/CD in order to build an artifact and sometimes even deploy it. Providers here, for example, can be Travis CI, Jenkins, and GitHub Actions. Then we move on to the artifacts phase. This is just like the registry phase, depending on your point of view. Are you a consumer that consumes your dependencies, or are you a provider uploading your own package? And finally, we are in the runtime phase, where our code is being executed. We will talk today, as I said, about research we've conducted in each one of the phases, besides the runtime phase, starting with the IDE phase. We'll talk about research about Visual Studio Code extensions. So first, why VS Code? There are many other IDEs. You can see Sublime, IntelliJ, and VS Code, but VS Code is the most popular one. How popular? According to a survey conducted by Stack Overflow, more than 74% of the users use VS Code. Now, VS Code is a strong tool, but its main power comes from its extensions. There are many, many extensions, starting from prettifying the code that you're writing, ending with Git integration tools and debug tools. How do you install these extensions? From the marketplace. You can just go there, search for the extension you want to install, and install it. You can do it from the web browser, as you can see here, or from the VS Code application itself. You can see the popularity of these extensions just by the sheer number of installs. You can see Python here has more than 76 million installs, and many others cross the 10 million downloads. Now that you understand that VS Code is very popular and its extensions are very popular, I want to shift our view a bit. When I tell you NPM packages, what are the associations that we are getting? So, of course, this is a security conference, and probably most of us are thinking about malicious NPM packages. And indeed, when you search malicious NPM packages in Google, you get many results about malicious packages stealing credit cards and tokens. And this is a good thing, the publications, not the malicious packages. But what happens if you search for malicious VS Code extensions? The answer is there are hardly any results. There are results about vulnerable extensions. But it's important to state that vulnerable is not malicious, and they are 2 different things. OK, there aren't any publications about malicious VS Code extensions, but what can an extension even do, right? The answer is that it can do anything the programmer can do. It runs on the local computer without any sandbox. It can run ransomware on his computer and even use his SSH key to connect to the organization GitHub repositories, private GitHub repositories, and change code. So after we know the dangers of VS Code, we want to see how easy it is to impersonate a popular extension in the marketplace in order to fool developers into installing it. What we did is we took Prettier, which is in the top 10 installs in the marketplace, and uploaded our own prettier with one T, and want to see the differences and similarities. Let's take a closer look. Here we can see marked as 1 is the URL. In the URL, there is a slight change between the two extensions, where in the original, there is prettier VS Code with 2 Ts, and now is prettier VS Code with 1 T. However, when at first glance, it looks quite the same, and not many look at the URL. What I really want to focus about is what's marked as 2 and 3. Here you can see they are identical between the impersonating and the original extension. This is because what you see here is the display name property of the publisher's name and the extension's name. Because this is a display name property, it does not have to be unique, and you can put whatever you want there. You can see at 45, the number of installs and reviews, which can be a good measure, but can also be fabricated. When we count everything here, it's very hard to distinguish between the impersonating and the original. But do not worry, Microsoft is here to help us. They published a guideline that says, can I trust extensions for the marketplace? Okay, that sounds good. And here are a few steps that you can take to make an informed decision. And one of the steps is take a look at the repository that is linked to the extension. But we were able to fabricate the repository that is linked in our extension, so this does not help us at all. In Microsoft Defense, other platforms have the same flow, and you can fabricate the repository. Now, up to here, we showed how we're able to fabricate extensions to look almost identical, but how can someone even get to my extension? I mean, when you search for prettier, you can see there are many results, and the impersonating extension that we uploaded is not even here. So how can someone even get to it? What happens when someone searches for prettier with 1 T by mistake? We are the only result in the marketplace, and you can even see in the box that it has a display name property, prettier with 2 Ts, making it very hard to distinguish. We took everything we saw here. We understood how easy it is to impersonate an extension and the dangers of installing a malicious extension, and uploaded a POC. This POC is the prettier that you saw here. They just gave us a ping when it was installed by a developer, and the results are in front of you. You can see here in under 48 hours, more than 1,000 developers installed our impersonating extension. Each developer here could have been the entry point for an attacker to his entire organization. Just imagine the scenario of a real attacker uploading a real malicious extension. Another flaw in the marketplace I want to talk to you about is the verified sign. What are the associations that you are getting when we see this verified sign? We are thinking that the platform has validated that the person behind this page is indeed who he claims he is. Let's look at example the social accounts of LeBron James. You can see LeBron James Facebook, Instagram, Twitter. He has a verified because the platform validated that the person behind this page is indeed LeBron James. Probably should have picked Steph Curry for this conference. Now, if we see in the marketplace, we can see SemiCloud here as a verified sign. Okay, has 2 installs, I'm not judging. Let's put our mouse on the verified sign in the marketplace. We can see there is a little pop-up that says, SemiCloud has a verified ownership for the domain semicloud.net. Wait, what? Let's look at the requirements to get a verified sign on the marketplace. You need to go to the marketplace, of course, select the publisher you want, enter an eligible domain, which is just any domain, and prove that you own this domain. This means that any developer like SemiCloud here can get a verified sign. Sam, if you are present or listening to this recording, nothing personal, thank you for your contribution to our research. Now, the sharp eyes of you can see that a verified location is near the display name property of the publisher. This means that an attacker can create a publisher account, get a verified sign, and then change it to prettier with 2 Ts, to prettier with 2 Ts. Probably then the most suspecting developers will install his malicious extension. Now, what I showed you here is the requirements before the publication of our research. After the publication, they added a little note, Microsoft, that says any changes to the publisher display name will revoke the verified badge. So this is a good step from the platform to mitigate some of the risks. Another good step that we saw is that Prettier got a verified sign. They did not have it before it. So the problem remains of what this verified sign represents, that just a domain, but it's a good step from the publisher side. Now we talked a lot about the marketplace. I want to dig a little deeper into what is an extension. An extension ends with VSIX, which is just a zip file. And when you open this zip file, there are many files, and there's a little magic file, the package.json file. From where do you remember this file? From NPM packages. What you need to understand from now on, it is VS Code extension. It's just like an NPM package, and there's all the attacks on NPM packages, like attacks on dependencies of dependencies. But this is for another session. Now, we showed earlier that there are many articles about malicious NPM packages. This is Backstabber. Backstabber is a collection of malicious open source packages that include NPM packages, and we use this database to learn patterns of malicious NPM packages to learn how we can identify maybe malicious VS Code extensions. For that, we use SEMGREP. SEMGREP is a SAS tool that you write some rule and search for patterns in code. Now, I know you can see what's written here, but this is a very simple rule that says that searches for exec or eval commands, execution commands that come after an HTTP event. We ran it across the marketplace, and here is an example of what we found. You can see here, upon installation, that you can do a GET request to the attacker's domain, and then you take the response body from the GET request and execute it using eval. This means that when a developer will install this extension, automatically there will be an HTTP request to the attacker's domain, receiving code to run on the developer's computer. Now, this can be a malicious extension, or it can be just very bad code written by a developer. Anyway, we reported it to Microsoft and was removed from the marketplace. Another thing we need to understand about extensions is that we upload it to the marketplace, which anyone can download from it, and maybe by mistake, you put secrets in it. We scan with a few secret scanning tools, as you can see here, a few of the extensions in the marketplace, and here you can see an example of after you open the zip of the VSIX, you see the token file. There was a token file that was probably by mistake uploaded, and this token file held the token to the publisher's marketplace. This means that when someone took it, he could have connected to the marketplace and changed the extension of the real publisher with his own malicious package. We can see there were also many extensions with AWS keys and many more. Of course, what you see here was revoked and was reported to the publishers. Okay, so a few mitigations and recommendations for the IDE phase. First thing first, the publishers and the platform's responsibility. The platform has a responsibility for us, the consumer, especially a platform that any anonymous user can upload to minimize our risk of exposure. Now, we saw that Microsoft indeed added the note about the verified badge, and this is a good thing, but there are many other flaws that need to be taken care of. The publishers also have a responsibility. There is a verified mechanism in the platform, apply for it. Help the users identify you. Are you a developer consumer? Before you install an extension, check the credibility of the extension. Is it new in the marketplace? Is there an extension with the same name? Is this really the publisher that you want to install from? Are you an extension developer? If you are, before you upload it to the marketplace, scan it with secret scanning tools. We saw earlier that a supply chain attack started from a secret in a Docker image file. There's no difference. It could be the next attack on your organization. Most importantly, what we've shown here is how an attacker can attack organizations and developers even before they write their code. We call this shift left left, attacking the developers. Now, what we've shown here is about the marketplace and VS Code, but we could have easily picked JetBrains and its own platform and other ones, so whichever IDE you're using, you need to be careful. Okay, we finished with the IDE phase about the VS Code extensions, and we're moving now to the SCM phase. We'll talk here about an attack in GitHub called repojacking. So first, what is repojacking? Let's start with an example. Assume you have an organization called My Organization, and within it a repository called My Repo. In order for a user to browse this repository, you need to browse the URL in front of you. Now the organization decided to change its name to New Organization. So the user will need to access the new URL instead. However, what happens if a user by mistake accesses the old URL? There will be an HTTP redirect and everything will be okay. But now, because the organization changed its name, the My Organization name is free for everyone to take. What will happen if an attacker opens the My Organization and within it the My Repo repository? There will no longer be a redirect, and users that by mistake access the old URL of the legitimate repository will actually access the attacker's repository. This is the core of repojacking. There are more scenarios like transferring the ownership instead of a rename, but it's all about the same. Now, there are some restrictions to this attack regarding if an attacker can open the repository, but just in 2022, there were many articles about bypasses to these restrictions. So in our research and this presentation, if we see a repository that has a redirect and the old username is available for taking, we counted it as vulnerable. Nevertheless, all the code examples you will see here were fully exploitable even with the protections deployed by GitHub. So up to here, we just saw that repojacking is just a redirect not happening. How can someone even exploit it for something? Let's take a look at some exploitation scenarios. A link in the code to the previous name. This can happen when in the code itself there is a reference to a GitHub repo that is vulnerable to repojacking. It can be to download the resource, which we'll see an example of soon, or in a Go module file as a Go import module. Installation guide references. This can be when in a README instructions, it points to the URL of the repository, but when the organization changed its name, they forgot to change the README instructions. We'll see an example of this as well. And hijacking links in posts across the internet. This can be when in a Stack Overflow, someone recommends a specific tool, but after he recommended it, the organization changed its name, and of course, he did not change his answer on Stack Overflow. Let's see some real-life examples. Here we have a Google project, Google Maps Steps, that was probably transferred to their ownership, but they forgot to change the README instructions. Let's take a closer look at the README. Here we can see Google instructs us to do a git clone to the Socratic org map steps and not the Google map steps. And indeed, when you access this URL, you can see that you get redirect to Google map steps, so everything will be okay. But when an attacker will create the Socratic org organization and will feed it the map steps repository, there will no longer be a redirect, and users that follow Google's instructions will actually clone the attacker's repository. Then Google instructs us to do npm install, which will result in remote code execution of the attacker on Google users. We made the POC on this repository. We got the Socratic organization and uploaded within it the MapSteps repository and wanted to see who installs it. It just gave us a ping. We got numerous results of code execution from open source users and developers of big companies. Another separate example I want to show you here is about a link in the code, and not README instructions. We see here we have the install SH script of the company, and within it the download URI that points to a zip inside a repository that is vulnerable to repojacking. We can see it takes this download URI, downloads the zip, and untars it. And from within the untarred zip, it takes the Dominus SH script and runs it. This means that when an attacker will create the YesGraph organization and within it the Dominus repository, there will no longer be a redirect. And when you download this zip, the attacker zip will be instead, and users that execute the install SH script of the original script will actually execute the Dominus SH script of the attackers. This is the proof that we control the YesGraph organization and we can open the Dominus repository. Now, in order for an attacker to really exploit this issue worldwide, let's call it, he needs to know the previous name of the repository. For that, he can use the GHTorrent project. The GHTorrent project. This project records all public activities on all public repositories in GitHub, like commits and pull requests. This is a goldmine for researchers and attackers. You can see here we have download links of specific months and years, and each link here contains millions of repositories. So what did we do with this information? Nothing beats a good statistic chart. We took a random month, June 2019, and extracted from it all the unique repositories' names. It summed up to 125 million repositories. From that, we took a random sample of 1% and checked each one if it is vulnerable to repojacking. That is 1.25 million repositories. And the results? Approximately 37,000 repositories were vulnerable to repojacking. That is almost 3%. If we apply this stat on the entire of GitHub, of every 100 repositories out there, 3 of them are vulnerable to repojacking, and we have a way to find the previous name. We disclosed our findings to various companies in the examples you saw here and many others. There are many other vulnerable organizations, maybe including yours, That said, we have a few mitigations and recommendations we'd like you to follow. Check all your GitHub links in your code now and periodically. You may never know when a repository will change its name, like a Go module. And do you want to change your organization name? Sure, do it, but keep it just as a placeholder, so an attacker won't be able to take it and exploit unchanged references to the new name. Okay, we finished with the IDE phase, we talked about the SCM phase, and now Yakir will continue with the registry phase. Yakir?
Okay, thank you, Lai. So we finished with the SCM phase, and now we move on to the registry phase. Here we will demonstrate you vulnerability that we found on NPM and was fixed by them. This also will demonstrate you the risk for developer. So first, what is package planting? In the past, NPM registry allow any user to add any other user as the owner of his packages. The ownership was added immediately without the approval of the new force maintainer. So it was possible for attacker to add other user as the owner of his malicious packages. As you can see here, first of all, attacker upload malicious package and then add a user with high reputation like the profile of NPM and Facebook as the owner of the malicious package. This is a really simple vector that could be done via the NPM CLI. First of all, attacker use NPM publish, then attacker use NPM add with the owner. And after this, attacker remove himself from the ownership of the package in order to make the package appear more innocent. This was also possible via the NPM website, but the reason why I'm showing you here is because there is another issue here. Some of you may notice that there is 2FA information disclosure. So it was possible for attacker to add any user he wished and check their 2FA status before trying to brute force or to perform password spraying. And this is how the landing page of the malicious package will look. As you can see, if you or any other developer in your organization somehow encounter this fancy malicious package, you may be installing it because it looks like maintained by user with high reputation. We reported our finding to NPM, which said they already working on fixing this issue. And as you can see, after some months, they actually implement a confirmation mechanism. So now, it's no longer possible to add any other user as the owner of your packages. And if you want to do so, an invitation message will be sent to their email box. There are some lessons that you can learn from the current vulnerability. First of all, if you are using NPM, it might be a good idea to check that all the packages under your scope really belong to your organization. And we can learn that you need to be always suspicious about the owner of your dependency. But I know it's really easier to say than done. So first of all, you need to evaluate open source project. You can do it by using different sources like DebDep, SocketDeb, or Scorecard that actually give you security ranking of packages or open source project before installing them. But you don't need to do it manually. There is already a browser extension that's called Overlay that was developed by an organization that's called SCAR. This organization tried to think about different solution and mitigation in the supply chain space. And I would like to show you a demonstration how it's look. It's still in progress, but this is the idea behind this browser extension. So let's assume that you or developer in your organization want to find answer for specific programming question, and then you find on Stack Overflow a recommendation to install request module of Python. But as I said before, you are a careful developer and you want to evaluate the risk before installing this package. So this extension could verify the credibility of this package and show you information for different sources. Okay, we finished with the registry phase, and now we move on to the CI/CD phase. Here we will demonstrate a vulnerability that we found on Travis CI, and this vulnerability actually put in risk tens of thousands of open source projects. So our research began after we realized there had been a huge increase in the different CI providers over the year. In the past, if you think about it, Jenkins and Travis CI were the only available tools. But now we have GitHub Actions, Azure Circle CI, and more. We start to notice that many open source projects start to migrate between different platforms. And sometimes it's still possible for attackers to find their own infrastructure, for example, on Travis CI, and this infrastructure may contain secret data. After a quick reconnaissance and POC, we found secrets that belong to really popular projects. We found out actually that the Travis API is vulnerable to IDOR, which means attacker could use as an anonymous user query any public log that Travis CI has of any project. And this is how it's look. It turned out there are more than 770 of available logs 770 million available logs. So, like the previous research, we like a lot of data, so we decided to take only 1% of the data, which sum up to around 8 million of available logs, and then we use different secret scanning tools and a warm word list. And as you can see, we found a lot of tokens that belong to GitHub, AWS, Docker Hub, and actually we found more than 73,000 of tokens that were available. In the chart in front of you, you can see the diversity of the token that we found, a lot of tokens for different usages. It's important to say that not all the tokens are equal, and some expose you more than others. Travis tried to censor some of the tokens that we found, but the diversity of the tokens in the log were too much to handle. You can see it for only for GitHub token, we found more than 20 different aliases. So let's connect all we have here. First of all, we have here a lot of log that anyone can access as an anonymous user. We have poor rate limiting process and incomplete censoring process, and this leads us to really dangerous situation. We report our finding to Travis CI, which respond that this issue is by design and they do not intend to fix it. And after our research was widely published, Travis started to mitigate the risk and deleted the log. We also report our finding to the respective service providers. All of them were alarmed and initiated a wide key rotation, and others verified that at least 50% of our tokens that we found were still valid. So there are still mitigation steps that we would like to suggest. First of all, if you had any old component or legacy component in your environment, it might be a good idea to delete them, because sometimes they can contain secret data. Our second recommendation is to rotate your secret periodically. Some of the tokens that we found were 7 years old. And our third point is you need to grant your third-party token the only privilege they need. And another tip is that it might be a good idea to scan with secret scanning tool any CI logs that you have or any output from your development process. Okay, we are on the last phase. We are on the artifact, and now we'll show you vulnerability that we found in NPM that allow attackers to disclose private packages on NPM. So let's first understand what is NPM private package. NPM registry allows users to upload to the public NPM registry private packages. The name of them must consist of 2 parts. First of all, @ then the username or the organization name, / and then the package name. As the name suggests, their content and their name should not be available to anyone. So, what is timing attack? When we refer to timing attack, we actually mean our attacker can, by observing different response time from the server, to know difference, to different input. Here, for example, we found that NPM is vulnerable to timing attack, and it's possible for attacker only by observing the time that took the API of NPM to actually disclose if private package exists or not. As you can see, if an attacker tries to access NPM API, first of all, you need to mention the name of the private package. And what's interesting here is not that there is no metadata or any information about the package, because attacker isn't have any access. What's interesting is the time that took the server to respond for this query. As you can see in the red color, when the package exists, it took the server more time to respond than if the package doesn't exist. And if the package doesn't exist, actually the time decreases over time because some caching mechanism. And if you want more specific data, we found out that it took the server to respond for us around 600 milliseconds if the package exists and you try to access it as an anonymous user, and less than 100 milliseconds if the package doesn't exist. So some of you may think, what is the order? What is the scenario behind this vulnerability? So let's assume that attackers find your private packages on NPM that's called hello world and belong to an organization that's called anytest.org. What attacker will do is actually to find if there is another package on NPM without the scope, and actually attacker will try to trick developer in your organization that forget to mention the scope of the package. Because we are all human and we make mistakes. But in order to understand it, I would like to give example for other platform, Docker Hub. If you know Docker Hub, you know that when you upload Docker images to the Docker Hub registry, the name of them must consist of 2 parts. The username / and then the Docker image name. And there is no possibility for any user to upload package or Docker image without scope to the Docker Hub registry. The only one that could do it is actually the Docker Hub team themselves. So the same situation is not possible on Docker Hub. And this leads us to the first point here. We need to unify the standard between different platforms on the supply chain area because each one of them have their own mitigation and nuance. And NPM have a lot of them. They really make a lot of effort in the supply chain space and try to secure the platform. Okay, so we report our finding to NPM, and they respond that because some architectural limitation, they cannot prevent this attack. So it's still possible, but with some mitigations. First of all, you need to gather a list of all of your public and private packages. Then you need to actively look for packages that try to mimic or to use type squatting in order to trick your developer. And if you find some, you can report them to the NPM team. And it might be a good idea to create placeholder package in NPM. Actually, this will eliminate the risk here. And if you want to read more about this situation and other related issue, you can read the excellent blog by NPM about avoiding NPM substitution attacks. And of course, as I said before, we need to think how we can unify security standard between different platforms. So let's sum up here some of the things that we told you. First of all, we have shown you how attacker can use IDE. Our attacker can use different GitHub dataset in order to find your organization name, in order to perform repo jacking. We spoke why it's important, what is package planting, and why you need to be always suspicious about the owner of your dependency, why it's important to rotate your key, and why it might be a good idea to create placeholder packages under the NPM scope. Each of the examples that we have shown you were really simple, but their consequences might be catastrophic to your organization. We also spoke about a lot of different mitigations for different steps and different tools. But there are many more and other tools with their own best practice. So you need to you need to do your own threat modeling in every tool and phase that you have in your organization. And another point, this was only the tip of the iceberg. We have shown you here only specifically example that related to specific tools. But when we, as a security researcher or security community, speak about vulnerability on the supply chain space, we mainly focus on NPM, PurePy, and Go. But there are many, many other platforms that do not get any attention from the community and from the security research community. And because of this, we need to unify the security standard.
Thanks for listening, everyone. If you have any questions at all, feel free to contact us here or just right here after the stage. Thank you. Or the microphone if someone wants.
Hey there, great presentation. So when you're talking about harmonizing security standards between all these platforms, because it's a long tail of development platforms that don't get a lot of attention from security researchers, what types of things do you have in mind? What types of standardization would you recommend?
I think there are many. Like we saw here, for example, in the ID, the verified sign. On first association, I saw it because, oh, wow, how did they verify it? And when I saw the domain, and I was like, what? This is not what. You need to understand that what the consumer thinks this is, and you need to do it like that. In the Docker Hub and the NPM situation, there are different scenarios. So maybe someone is used to Docker Hub, and then if he moves to NPM, he will make mistakes as the consumer. So there are many other possibilities. Like this is the scope, this is the verified. It's endless, but I think that they need to take like the main things and like say this is how we do it, this is how we do it, this is how I do it, and no one will like, you understand?
And in my perspective, NPM have a lot of announcement around the 2FA status about enforcement of 2FA, and now they actually, I think, implemented it on GitHub. But other platforms do not have the same perspective on their platform. And even when another perspective is when you report a malicious module. NPM really do a good job when you report about some malicious packages. But other platforms actually do not do nothing. For example, when we report about some VS Code extension, it took a really long time to delete them from the registry.
Can I ask you one more?
Yeah,
Yes, of course.
And I apologize because this is like the standard question for RSA, but you use the Stack Overflow example as, how you might, a developer might be prompted to use a particular extension or library, right? Just in a Stack Overflow example. But of course, going forward, right, it's probably going to be a chatbot that's making code recommendations to you. So any sense of whether, ChatGPT or these other chatbots are also passing on, how developers should kind of orient themselves to the types of code recommendations, code examples they're going to get out of a chatbot and what risks are in those?
I'm not an expert in ChatGPT, like a recommendation of his kind, but like in this example, even if you're in Stack Overflow, not even ChatGPT, it gives you a recommendation for a specific tool, you won't get attacked by browsing just the repository.
Right.
If you see redirect, understand that like, okay, maybe I should go immediately for the, after the redirect, for the URL after the redirect. This is for this example. Each one has its own attack surface, and it's very hard to know if his recommendation is okay or not. It's hard, I agree.
Okay. Thanks, Guy.